So first I'll start up here. All right, guys. Anybody feel comfortable trying to tell me what correlation tries to see? What's the goal of doing a correlation problem besides getting a good grade in stats class? What can correlation do for us? What does correlation mean?
What's related?
You could even use an example that I've already used if you wanted to. That's the kind of question I wouldn't get any volunteers for. I understand that. So, section 10.2 and 10.3, they kind of break the correlation problem down. They could have made that one single section, especially for us, because we get everything we need in one go from the calculator, right? So maybe it is because it's been a week. So if you have a list of data that goes together. So remember last time we had, like, somebody has 2 beers, they get a 75. They have 5 beers, they get a 41. They had no beers, maybe they get an 88. So blah, 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 blah. So one of the most important first things you realize is, if you put this data in list 1, you put this data in list 2, would you sort that data?
No.
No, hell no, please don't. Right? You always get somebody to do that, and everything's a perfect line then. You know, yeah, of course. You force that to happen if you do that. These have to go together. Ordered pairs. All right, so that goes with that goes with that, so forth. Cool? So that's the first thing you realize. Second thing is I showed you the formula that goes along with this, and this is the one place where I'd rather use the technology than use the formula directly. Because the formula is just loaded with a lot of stuff, and it's I pointed out that you can see the standard deviation in it. So what letter, when we try to measure the strength of a relationship between X and Y, what letter do we use to measure that? R. Good. And what's that called? Like, R, man, what the hell? What do you call that? What's the name of that statistic? Who remembers?
Relation.
So it's a correlation coefficient. I love it. So COCO, right? Correlation coefficient. You don't hear a lot of people referring to it as COCO. Maybe we should. The correlation coefficient is also called the Pearson product. And of course, my teacher's name was Pearson, with no relationship to the actual person it was named after. Correlation coefficient. Now tell me something about that. Hopefully this makes sense. Now, I always saw it as a 2-dimensional standard deviation. The more my points got away from the line, this R would become closer and closer to a certain value. So the more my points are away from a straight line, what happens to my R value? Closer to what? 0. So that's beautiful. So a value of 0 would tell me that there is no linear correlation, at least. That's the only one we're going to look at, right? Linear. So if I get an R of exactly 0, that means there is absolutely no relationship. X changes and Y doesn't care. It does its own shit, right? You with me? Sort of like whatever I do tomorrow versus what somebody does over in Alaska. They probably have nothing to do with each other, unless they called them and said go outside and jump up and down. So R could be between what and what?
-1 and 1.
Beautiful. -1 would mean it's
negative, correlate, negative.
So that line would look like what? If I lined it up.
Like
Yeah, good. I got to think about it from your perspective. It would be like that. Good. And all the points would be perfectly on that line. So if it's any kind of 1, that means it's perfect. The minute I kind of reach in, so I'm God, I reach in and say, I don't like that point there. I start messing with the points. Right? Because that's what gods do very often. Just read your mythology. It's good to mess things up. Then my R goes away from -1. It goes to 0.9, 0.8, 0.7. The more I pull them apart, the closer it gets to 0. You kind of with me? So very few things in the real world have an R of exactly 1 or -1. There's always going to be something. So like, there's always going to be the guy that can drink as much as he wants, or girl, and the next day they'll do fine on the test. There's always something that's going to mess up whatever trend I think is going to happen or that I can almost see happening. Bless you. But the things that would be really close to this would be kind of silly things. Like if I wait some time and I watch a kid, he's going to grow. And if I chart his growth, I should get a relatively straight line for a little while. Thankfully, again, not forever, so you don't have some weird old 50s sci-fi movie with some dude, 50-foot dude, right? Thankfully, the line slopes off. Okay? Okay, so that's the idea behind it. So then, what do we actually do in the calculator then? Of course, we forgot to bring some. You guys can watch. Here, so you guys help me out. We're going to make up some data. And I want this data to have let's start with a positive R. So give me some numbers that are increasing, like 2, 7, 9. Give me some numbers. 3. 6. 9.
12.
You guys are funny. Sure, why not? 12.
22.
22. There we go. I like it. Now, in order for this to have a positive R, what has to happen with my list of Y's? They have to increase. If they decreased while X increased, that would be a negative R value. That would be a down slope. You with me? If I move over X and my Y goes down, that's a downward slope. Holy shit, there was a whole reason to learn that in algebra. That's crazy. But yes, there was. So, what can I put here? Let me start this off. 48.
62.
62. 72.
115.
115.
150.
Let's say, what do you say?
150.
150, that's fine. Okay. My grandpa there. I just heard what'd you say? All right. Let's try this. If you have a calculator, you can try this out with us. If you don't, then I'd like to see you try. Here's the stuff from last time. So that's kind of like what I'm talking about there. Just go into list 1 and list 2. So list 1 will put the X's. List 2. All right, cool. All right, list 1, list 2. Now, if you just hit graph, freaky things will happen. That's not good. So 2 things I need to take care of there. One thing, that line has nothing to do with my data right now. So I want to go to y equals and take that line out of there. Now, how do I see my data? I only see one point there. That sucks. Zoom. 9. So zoom, and just to show you once, holy crap, this thing has a lot of options.
Zoom 9.
Zoom 9 is zoom stat. Of course, you don't have to go all the way, you just hit 9. But it'll always pull up your... Now we did a damn good job. Because it wasn't that hard of a thing to do, but still we did a good job. That's a really nice straight line there, right?
Sort of.
Oh, now, if you weren't here last time, you have to go into second y equals. So you see a screen like this?
Yeah.
You hit second and then y equals. You should be in the stat plot screen. And you need this, one of them turned on. So are they all off right now? So if they're all off, you hit enter, and then hit enter while you're on top of on. So now your stat plot should be turned on.
All of them or just one?
Just one.
Oh. Yeah.
Oh, you're good. So then hit zoom 9. So now you got weird stuff in your y-equals. How you doing? Good? All right, sweet. Everybody else all right? Oh, invalid dim. That means that they don't match. The dimensions for some reason they don't match. Looks like they had fun. Let's hit to L2 and L3 for some reason. So L1, L2. Holy wow. Okay, there you go. Oh. 1, 2, 3, 4, 5. That's good. Oh, you're there. You're there. Cool. All right. So we all here?
Yep.
Huh? Okay. So how do I get the equation of now? There's always two sides to a math class. There's the how the hell do I do it, and then there's the what the hell's the idea behind what I'm doing. Stats is one of the earliest, most important ones to get the idea that there's a concept and there's a process. So whoop-de-doo, I got a bunch of points, right? Now I don't know what this really represents. I don't want to make anything up for what this means. But these data points, how are they? How does y change while x changes? They change really closely. They're really heavily correlated. They're very tightly correlated. When x moves a little bit, y moves by about the same amount. That's why it comes out to a nearly straight line. Right? It's a nice continuous slope. You kind of with me? So I want to figure out exactly how strong is that. I feel that's pretty strong. Right? I would guess that this r would come out to be
0.9712.
That's weird. That's exactly what I was going to say. And I want to be able to, you can kind of draw this in yourself. You can kind of see where a line would go through and average where the dots are. That's exactly what the line of best fit does. And I love this idea. The line of best fit is a graphical average of all the points. And the R is sort of like a graphical standard deviation. Of course, it's got different values than we're used to. It can go negative, for example. But it's the same idea as a standard deviation. It changes by moving my points further and further away from the average. That's exactly what standard deviation does, right? Okay, cool. So, let's all catch up. How do I get to that R value and that line of best fit?
Calc. Stat. Calc.
Stat.
Calc. Lin, rig.
And the one with the equation of a line is kind of a giveaway. Right,
Number 4. Yep.
And of course, if you weren't here last time, just let me know if you don't get all this information. No?
No, I only get like 60.
Anybody else not get all that information? A few of you guys. Okay, I was going to say, if there's only one, then I'll just change yours. Anybody who doesn't get the R's, do this. You only have to do this once. You ready? I'll take it as yes. It's second, 0. There's nothing you have to memorize, nothing you have to do, so I'm not going to explain it. Go to, hit the x to the -1 button, see that? Where it's got the little green D. So you can go to the D part of the list. So do you see day of week at the top now?
Which one is it?
This button here, the x to the -1. It's got the little green D. So now it should take you to the D section of the list. Go down till you hit diagnostic on. And hit enter. Enter. That was, like a lot of things on this, that was a little anticlimactic. It's like, done. Go stat, calc, number 4, do the whole thing again, and pop, you should have your R stuff.
Yeah.
Okay, not quite street magician level, but still. Sweet, all right, good. Okay. So somebody tell me something about this. Tell me anything about what these numbers mean. A is the slope, kick ass, right? It's just the same as M, except it's stat, so we couldn't be the same as pure math. We had to make our own thing.
Y-intercept.
B is the y-intercept. I love it. R squared we don't talk about too much yet, but that does, I talked about it a little bit. It explains 94% of the variation in the y value is explained by the variation in the x value, which means there's some other variable happening, which in this case was just our imagination, just coming up with numbers. R is the value that directly measures the strength of the correlation.
You got 31, I got 30. For B.
Okay? I don't know what to tell you.
I got 31.
You got 31?
Yeah, I got 31.
Okay. You guys all right? What happens?
Yeah.
Was I mean?
I found it.
Good. All right. Now, guys, if I want that line to show up on the screen, where do I go?
Rewrite the equation.
Where?
On the y equals.
Don't have to do second now. You just have to hit y equals.
Plot it and you write.
So if I want to put in a function where I can solve for y, and we got it. We got y equal 5.6x plus 31.1. I could put that into y equals. So go to y equals. So it'll be 5.6x plus 31.1. Graph. And there's my graphical average. Kick ass.
Can you hit y again?
Yeah.
Where are we at, sir?
Can you hit y equals again?
Yes.
Thank you.
And I got those numbers from the AB from the previous screen. Okay. So real quick, if I wanted to make R worse, what could I do? What's the easiest thing I could do to make R, what do I mean by worse? I mean make it closer to 0. Make it less correlation. What's the quickest thing I could do? Make that a more general statement. Actually, it's
Reduce y.
I could take like 150 and instead make it go against the trend. Maybe make it 100. I love it. That goes against the trend, right? You with me? So if we do that, let's try it. Our R was 0.97. So if we go to Stat Edit and we change that last one to 100, and then we do our regression again. That one change, if I make that 100, it goes from 0.97 to 0.76, which only makes sense because now it's like, hey, it looks pretty good. I know where I'm going. Holy shit, right? So that's what I've basically done. And if I look at the graph, now my old line is still up there. You can see how the old line doesn't really work anymore. So my data, now it's down there. So my line now is gone. 2.88x plus 49.4. I could do that and it would go through the points better. You guys kind of with me? Of course, you don't get to do that. You don't get to go, well, this guy said 150, but let me just change it. But I'm just saying, in general, that's how R reacts to the data, whatever your data is. How we doing? Okay. Now remember, the one piece that's kind of missing here to really tell if R is strong enough. And that came from that table I showed you. But remember, on the test, I'm just going to tell you the number. So in this case, what is N?
5.
5. Good. I got 5 data points, right? So for an N of 5, my R has to be 0.88 or better. And now let me say that again. In order to show evidence of correlation, my R value has to be bigger than 0.88, I think I just said.
So
You guys kind of with me?
It's not greater.
So does this show correlation?
No.
No. Okay.
The one is.
Yes. So if I said, what if X was 14? What would be my prediction for what Y would be? Can I use the line that I see here? Let me make sure I understand your answer. Is that like a negatory? Is that like a no, sir? Is that like a... All right, right now you got the I just said a word. Rhubarb. Yeah, so this equation, that equation tries to model the data. That's what that equation tries to do, right? Now, I have a very small sample. So you know if you have a smaller and smaller sample, the amount of evidence you need becomes greater. That's why R has to be so high, 0.88. If it's below 0.88, I don't have evidence of correlation. If I don't have evidence of correlation, can I use that line to do anything?
No.
I kind of led you there with my tone, but no, of course not, I can't. That line says this is the trend. If R is not strong enough to show a trend, you can't use the line. So then how the hell are you supposed to answer this question? If X is 14 and I have an equation, I want to plug it in, but I just said you can't. Nah. So my best guess for what Y is going to be before chapter 10 was always the average of all the Y's. So that would be your same answer now. If your line does not help you refine that guess, your best guess by itself is always the average. We know that. My best guess of the age of people at Grossmont is the average of 50 randomly selected students. That would be a really good guess, right? That should be pretty close. So if I don't have a line to make it more precise, I still go back to the average. Why am I spending so much time talking about this? Because you have exactly that kind of question in the homework. They'll ask you, here's the situation, here's the equation of the line, what if X is 20? And everybody's going to blindly just throw a 20 in there, when they're going to tell you R is 0.07. You're like, that's pathetic. I'm not going to use a line for that at all. I have to give the average value. That's it. That's the best I can do. You guys kind of with me? Yes, sir.
So use alpha equals 0.05?
Normally, yes. And don't worry about it. I'm not going to give you the table. I'm just going to give you the cutoff score. Yeah. Okay. So here, let me do this.
Always have to be 0.88?
Say again?
Always to prove...
No. That's for a sample size of 5. And a level of significance of 0.05. Little alpha dude. Oh, yeah. I think I told you guys. There's a whole hypothesis test you could pull for this. But we're not going to do that. We're just going to go straight to the, what's the cutoff score? Did I make it or not? In this case, we did not. Before I screwed things up, we did. We had 0.971. That was fine. So let me do this. In the interest of time, let me give you the practice final. And turn to the back of it. Lost count. See what happens. Have you guys ever eaten at Bronx Pizza down in Hillcrest? Who has? Anybody? Oh my God. I think they put crack in the crust or something. It's yummy. It's so yummy.
That's a theory, just get the best.
This is true. I really, really wanted to go that far.
Sure. So do all the classes not go over the formula for this chapter 10?
Most of them do.
This test for the
Most of them do. No. I mean, they don't go over the formula.
calculator.
In fact, some of you guys might know or might guess, I actually do more by hand stuff than most other teachers. But then you learn this stuff, right? That's what I hate, is to get somebody who wants to tutor stats and they know the buttons to press, but you can't explain to me what the hell's going on. All right, so what I want you to do, number 5, on the back, it talks about Bronx Pizza, how close you are, and what your weight is. My hypothesis is that there's a correlation. So go ahead and don't worry about part A. That's a confidence interval. Do part B, C, and D. Oh, look on with somebody near you if you didn't bring a calculator. You guys will like this. The benchmark score is 0.666. Or not greater, sorry. Yeah, greater. One of my students in my other class would say that's so metal.
He's so seriously. You looked at one too. Oh, here's something about the one too. You can have like a gems. I have exactly 666 with gems. I see a show called Monk. I couldn't sleep because I didn't know why. Because of like spirits. I mean, I don't know what they are, but I'm worried that they might be. So, it's better if I believe it than I don't.
Yes.
Well, we did. So we're supposed to do number. So, do we do number A?
Oh, don't worry about A. Don't worry about the confidence interval part, guys. Just do B, C, D.
So the R.
Don't worry about the confidence
So
interval.
it's like strong negative, then? Because that's what I got for the R value.
Good. I like it. But tell me more. So strong, negative, correlation.
Negative.
Strong negative correlation.
How did my R turn out positive? 182.
Freaky.
Yeah.
I think that's
Oh.
R squared.
That's our score there.
R is.
There's R.
I think that was R squared.
Yeah, like an R's at first.
Am I doing it right?
Beautiful.
So half
The
a mile.
further you get away,
0.5.
this person 13 miles
Half a
away
mile. 0.5.
versus this person 3 miles
Half a
away.
mile, yeah.
You make X get bigger, meaning you move further
It's not
away,
bigger,
the weight
so-
goes down. So you move, it goes down. You move, it goes down. That would be a downward slope. So R should be
I got it.
Yeah, so
0.66.
negatives and positives. Yeah. Just look at the pure number,
Oh.
right? So like T-scores, the negative just means what side it's on.
Oh, so it's greater than because we took the X.
There's sufficient evidence to reject the claim that there is no correlation.
0.66.
But I mean, you don't have to say all that. You just say there is correlation.
What does that
There
mean?
is definitely correlation.
If it's above the cutoff range, what does that mean?
Strong negative correlation.
Good. Yeah.
I'm writing this down. Good answer. So do we have to plug in this
Yeah, so it's
0.5 to that equation?
Is it weak or strong? It's how compared to the cutoff. It's not 0.7. It's not point. It's 0.9. So it's really kind of decently far away from that cutoff. So I'd say it's strong negative correlation.
That's it?
If you came out with 0.7, you'd say
Yeah, because we can predict, we use that equation.
because it is there, but it's barely past the cutoff.
It doesn't matter.
It's absolute value. Absolute value.
Some people like.
The negative sign doesn't really matter.
I don't know what's.
Negative sign just tells you it's going down.
You don't believe in ghosts.
Good.
It's scary.
That's what the
You
data
saw one, you
or
called
the
it.
data was completely made.
How would you feel if you saw a ghost?
What the hell was I on?
That's what I was thinking.
Was I high? Did someone drug me?
I was asking like if I would ever see a ghost, would I believe in it? It's like no. Did you sit at that number? Nah.
How you guys doing? Did you get the R value yet?
Negative point, not R.
Negative 0.907?
You just put negative 9.1.
Sure. So that's plenty good. I know I had, again, you gotta excuse me, negative values so often don't really mean anything. We very often just look at the pure number. Like a T-score chart only gives you positive values, because that's all that really matters. You put the negative on there if you need to, right? So R of 0.91, I don't care if it's negative or positive, is definitely further away from 0 than 0.666.
Well, what are
So what does that mean?
Strong negative.
Good. It's definitely a correlation.
Strong negative.
There's evidence that there's a correlation. It's way past 0.66, right? So that means it's decently strong, or if you just say strong, it's beautiful. Strong negative correlation.
Oh.
So you got to tell me, is it weak or strong? You got to tell me if it's positive or negative. Cool? Yes?
So that cutoff line tells us if it's strong enough.
Yeah, if I would have gotten 0.7, I would have said weak negative correlation.
Regardless of.
If I would have gotten 0.5, I would have said,
No. It's weak.
no, what would I, if I got 0.5?
It's less. It's not like.
There's no correlation. It's not even there to be weak or strong, right? Weak or strong. It's not even, it doesn't exist. There wouldn't be any correlation if it's not past this. If I get a little bit past this, some kind of weak, we got to 0.91, just about. That's decently strong, right? So let me try to, how do I graph the dots?
You write the equation.
I like this. Just press graph. If I just press graph, I get that.
Zoom 9.
Good. Let me go to y equals and take that out. I hit zoom 9.
Mm-hmm.
Now that's why I got negative 0.91. This is pretty tight, right? The line would go right through there, be pretty tight. You can see the trend pretty well. It's not negative 1 exactly, because there are some, they're off, they're not all lined up perfectly. So what's the equation for the line?
Negative 2.87x plus 218.
Negative
87x
2.87x
plus 218.58.
218.58. 0.58. 0.6, sorry. Oops. Probably put the wrong negative in there. Yeah. Negative.
That's right. Oh no.
I got 0.689.
Go back to y equals. Yeah,
If it's greater than the cutoff value, then it's stronger. Once we show evidence.
It has to be greater to
Say again?
have a correlation. If it's a little greater than that.
No, you had 689. That's the problem.
A lot bigger than that.
689. 869 would be fine.
Because
Everybody get that?
it's such a great correlation. Because it's less.
You guys doing all right?
It has to be at least this great.
No.
Just to at least have a correlation. At least, yeah.
This is obviously a silly example, just meant to get the process down. But I think I already told you a little bit about, I'm pretty sure I went through my boring example about the freshman coming in and I placed him in the first math class.
Yeah.
Remember that? Some of you guys weren't here, so you're like, actually, no, I don't remember that. So I took all the high school SAT scores and their GPAs and I made it into one number. I put all those together and then I gave them a replacement test. Then I did correlation. And it came out to be like 0.8 almost, 0.7 something. So that's pretty good correlation. So the next year, I took the incoming freshmen, put in all their scores, and then used my line from last year to predict how they would do. And that came out pretty well. And now I can use my new data to make my line even better. So every year, I would just put more data from that year in, and my line would just keep getting better and better. So I really want you to understand this. As all statistics is, individuals can do whatever the hell they want to. But this does a really good job overall. So I would call the math department and say, using my line, I could see exactly where I thought people would place. And I said, we need more math 110s and less math 90. You with me? Because even if somebody I predicted going to 90 who actually went to 110, somebody from 110 I predicted would be there would actually go into 90. So it all kind of averages out in the end. You kind of. So it's sort of like, this is not exactly the same, but you've all heard the term metadata, maybe. Metadata. This has to do with, anybody who's heard it know what it's got to do with recently?
I have an idea.
You like that?
Like internet information.
Did you hear that? Did you hear that click? Somebody breathing? NSA? NSA? So the NSA collecting phone records, saying it's not anybody's individual data, it's metadata. It's just looking overall at phone usage patterns or whatever. You with me? Which is not, come to find out, not really true. But that's what this is kind of looking at. It's looking at the general average way that things work. So if I look at how a human grows, not everybody grows that way. So that's when you see the actual charts, you see this like spread. Or here's a perfect example. I don't get to use this example much living in California, but I used to live in Florida. And California, we have wildfires. You all know that. But in, shoot, let me see where I can get this real quick.
You have hurricanes down here.
Yeah, hurricane. Hurricane. Yeah, perfect. This is the one that went right through where I used to live. Have you guys ever seen this before? Anybody have people that live on the East Coast that you know? And then maybe you go here? So to see this black line here would be like the average of what a hurricane has done in the past based on the current conditions. Are you guys kind of with me? And then this cone, the cone of uncertainty, right? Sounds like something from an old Get Smart thing, but the cone of uncertainty is kind of like the standard deviation away from it. So maybe a hurricane in the past was here, and there was one there, and there was one there, but most of them would follow this line in the middle, that graphical average, right? Or maybe nobody would be on the line, but it still graphically averages where they would be. You guys kind of follow me? This is the math is close, and it's not exactly the same. You could probably guess that there's more variables in here. It's probably not. It's obviously not straight correlation, although this does kink. I think now that they got like a curve to it, but it's still close enough to what we're doing to be a good example. So you guys, of course, we live in California. I think we've only had one tropical storm that hit back in like the 70s or something.
What we got is earthquakes.
Yeah, earthquakes and fires.
That's going to happen.
Florida, we got hurricanes and sinkholes. That was exciting. Okay. So, any questions from we haven't finished this out. Part D. Predict the weight for somebody who lives half a mile from Bronx Pizza.
That's 117 pounds.
So our line equation was, what was it? Negative 2.87 plus 218.58.
58.
58?
Yep.
Sure. Okay. And you'll love this. See how the little Y dude has a hat on it? Because when I plug an X value in here, am I going to get exactly the right data value that goes with the X? No. So, for example, before we do part D, this is part D star. If X were 11, what would I predict Y to be?
Plug it in.
Somebody help me out.
217.7.
Something went wrong there, buddy.
187.01.
That sounds better.
Still
187 point blah, blah, blah.
01.
Now look at your data real quick. Do you see somebody who lives, I see a couple people that live 11 miles away. Do you see that? Here's something, I didn't plan this, but it works beautifully. Do you see the people that live 11 miles away? What's the first dude? How heavy is he? And what's the second dude? What's the average of 180, 194? Now that's amazing. All right, it's not going to always work that beautifully. It just happened to work that beautifully. I don't have 2 4s, but if I put a 4 in there, it should come out pretty close to 195. Because my R is so strong, I trust this line. So the real question says, what if I live half a mile from Bronx Pizza? X equals 0.5. What am I looking at for my...
That was a 217 one.
217.4.
217.45?
17.145.
145.
145.
217. So if I live half a mile from Bronx Pizza, I can expect from this study that we did that I would weigh 217 pounds roughly.
It's above the walking distance.
Yeah, and you'd hope the walking would actually maybe offset a little bit. Yeah.
When I plugged in 4, I got 207.1, like, even though it says 190, 95.
Oh yeah, so it's not going to be perfect.
Oh.
So that would have been an even better example to give. And it's not going to be perfect. And what part of this tells me the line of best fit will not be perfect? R. The fact that R is not 1 or negative 1. I know there's going to be a little bit off, but it's going to be good enough. Right? And that's what I love about stats. That's what people hate about it. But real life, you don't know exactly the right answer, but stats makes it good enough. I can predict well enough. Just to try and improve my grammar.
It's not perfect unless R is 1 or R is negative.
All right, how you guys feel about chapter 10? Okay, all right, good. It should be one, I'm hoping most of the time people love it because it's all in the calculator, which is nice. But it's just, are you able to explain yourself? Those questions normally throw people off a little bit. All right, so in a little bit of time, because I know you guys are all like, dude, don't you teach here and shit? But I got to leave early today. Nothing exciting, nothing fun. I got a meeting at Cuimaca. District-wide Coordinating Education Council is what it's called. It's always just as fun as it sounds. Thank you for that. You want to come? Sounds like you're... I got a guest coming. Yeah.
Are we getting the answer key for this or no?
Yes. So this Wednesday, I'll have an answer key for the practice final.
Is this how long the finals going to be? Or
I don't know. How much time do you guys normally have for a test?
Hour 50.
Yeah, so we start at 2, and we go until 3:50. So you normally have 2 hours. How much time will you have for this final?
2 hours.
Ah, so it cannot be longer than a normal test. You with me? So I am going to have to sacrifice a few things just to fit everybody in. But what are some things you know are going to be on there?
Chapter 1, chapter 2.
You know there's got to be a problem like number 5. I love it. You know there's got to be a problem like number 6.
3.
You know there's going to be almost exactly number 8.
Yes.
And I'm hoping for more than 20% getting that one right. Yeah.
So we're just going to review like the normal curve. We don't have time to review like the skewed like graphs. Like
We're going to get into it. We're going to try again. You know there's going to be one like number 3. That's chapter 5 stuff. One like number 4, that's the binomial probability. So what am I going to cut out? I don't know.
we're not having chapter 1, right? Anything from chapter 1?
Not really.
You said chapter 4.
Yeah, probability. Do I have probability? Yeah, number 2 is probability.
Number 2?
Yeah, number 2 is probability stuff.
is that chapter 4?
Chapter 4.
Chapter 4.
Yeah.
Number 2,
All right, guys. So we really only have time. I need to do at least one section that deals with chi-square. We might as well do the section where it first shows up. So section 7.5 is one of the ones we skipped earlier that is listed at the bottom of your homework sheet, right? So we're going to do 7.5, and then on Wednesday we're reviewing for the final, but I am going to sneak in a couple of comments about how this distribution could be used in other ways, because depending on whatever you're going to go into, psychology, business, all these other areas, they use this chi-square is called chi-square, not king chi. There you go, I got one Dragon Ball Z person. So chi-square, all right, looks like an X that's had a rough life or a really good life. I don't know how to get that. So chi-square distribution, one way to create it, if you're talking about variance. So chi-square actually is a more general idea than the normal distribution. Chi-square is able to handle standard deviations. So if I take a sample, I know its average is not going to be the same as the average of everybody. You with me? Right? So if the real average age was 35, and I take a sample and I get 31, and the standard deviation is the new standard deviation is 2.98. What can I do with that data? What can I immediately see about that sample mean that I got? This is a little bit weird of a question, but what can I do with everything I've given you there? This is the mean. This is my sample. This is my standard deviation of my samples. What can I calculate from those values? Immediately, just using those three values. What can I calculate? Z-score. I love it. So I can see how far away is this from what the average of everything is. You with me? Divided by
2.98.
2.98. It's like negative 1.3 something.
Negative 1.34.
Blah, blah, blah. Now, so that's old news, right? We've done that like crazy amounts of time. It's chapter 6 and on. It's basically z-scores. So what this does is it's more general. It could actually capture that same idea, but the immediate use I want to is for variance. I can't use this to talk about variance. So when you take a sample, you can get a variance from the sample, right? Now, what the hell is a variance again?
The square root. The square root. Square root.
It's before I take square root. It's the sigma squared or the s squared. You with me? So if I take a sample and I get a variance from the sample, don't worry, I'm not going to. Can you imagine? Yeah. If I take a sample, I take a variance from the sample. Is it going to be the same as the variance of the whole population? Good. The right answer is probably not. So whatever I get from a sample will probably not be the same as the population. But the larger my sample, and the more randomly selected it is, the closer it should be. And that's the whole idea of the normal distribution. It should be closer. This one, why can't I use this idea to talk about my s squared versus what the real population standard deviation is? Because z-scores are built off of a given standard deviation. I can't compare different standard deviations. And it's like, oh shit. You guys semi with me a little bit, a little tiny bit. Littlest, tiniest bit possible. Okay. So what we use is this chi-square distribution. So to make a chi-square distribution, to get the value of chi-square, and be real careful, that square is actually a part of the symbol. You don't really take a square root to get chi by itself. Be careful. Not really. It's part of the symbol. Chi-square, let me just do this. Is equal to that. So if I wanted to make a chi-square distribution, if I want to make a normal distribution, I would go out and I could take a sample of 40 students and find their average age and plot it. And then I could go find another sample of 40 students, find their average age and plot it. If I do that for all samples of 40, I'll end up with a normal. How do I know it's going to be normal? because the sample size is
Greater than 30.
greater than 30. I love it. You guys kind of with me? So I can take a sample, plot its average, sample, plot its average, sample, plot its average, average. To make a chi-square, I take a sample, I plot its standard deviation. Right? But actually what I could do is, for a normal curve, I could actually take a sample, calculate its z-score, and plot that. Then I would get a standard normal with 0 and 1. So I can do the same thing here. I can take a sample, get its standard, its variance, calculate this, and plot it. This is sort of like the z-score. It's sort of the same as the z-score. So let's try a specific example out, real quick. This is not what we normally do with this. Let me see. Okay, you guys, let's see. This will be a good review. If you don't have a calculator, I'm doing something again to screw you over. Go ahead and put those into list 1 and calculate the standard deviation.
Isn't it standard deviation of x bar?
No, this is just values. These are what x is. Just figure out what s is.
Okay. 3.34.
Seems a little high.
3.34.
That sounds better. And I could tell that how far away are the average of these? What do you guys give for the average of these?
68.5.
68.5, pretty close. That's good. Sorry, I was trying to get close, but I didn't realize you got that. And they all are like 4, 5.5. They're all pretty close, right? So it kind of makes sense. The average distance is about 3.33. So I know if I get 19, not to pick on you back there, but if I know if I get 19, it can't be right because nothing is 19 away from the mean. So how could the average distance be 19? So that's immediate, like I did something wrong. So S, you got 3.34.
3.4. Yeah.
So what's S squared?
11.16.